All right, folks, happy February Town Hall. For those of you who I've not met, I'm Maggie. I'm the Community Product Manager for DataHub. We've probably seen each other in Slack, but super excited to have you here and to get you up to speed on what we've been working on. Let me share my screen. Thank you for the shout out on my sweater. This is my DataHub sweater. Pretty cool, not gonna lie. All right, so welcome everyone. We have a jam-packed agenda once again, shouldn't surprise anybody. We are gonna I'll do a quick community and roadmap update. Then we'll be talking about some of the kind of highlights of our project work. We have a case study from Edward to walk through a recent contribution for YAML-based ingestion, which is super exciting. And then we'll be looking at Lineage Impact Analysis, data quality with great expectations, and hopefully we'll have time for Q&A. We'll always stick around if folks have questions afterwards. So let's talk about the community. We're still seeing a huge uptick in number of folks joining the community every week. We're seeing about 75 people a week. We're just shy of 2,500 folks, which is just outstanding. I'm so happy to, that we're still continuing to grow, and I continue to hear feedback from folks in the community that people just love how vibrant it is, how much activity is happening, how much support they're getting, etc. So reminder, we have office hours every Tuesday. It's just a half hour for folks to drop in. You can bring any and all questions related to DataHub. It's just a chance for folks to get some live support there. And then reminder that if you are looking for opportunities to contribute, or if you want to show something that you have worked on, show it with the community, we have those two contribute and show and tell channels. And then we're also seeing more and more activity in our advice channels around data governance and metadata modeling. So I encourage, bring your questions, your experiences, and let's just keep those conversations going. And then as a reminder, Shirshanka and I will be speaking at Data Council in Austin. The dates, it was originally supposed to be in January. It's now going to be at the end of March. If you are interested in joining, or if you want to go to the conference, you can use the DataHub 20 promo code for 20% off. And if you are going to come, let me know. I'd love for us to meet up safely in Austin and talk shop a little bit. All right, this is my favorite part of every town hall, community shout outs. I love this community. We have a few new official adopters of DataHub. So huge shout out to Bharat over at Zynga, the whole Udemy team, Karem, Sila, and Mert. Also special shout out to Sheriff. I know that he recently joined another company, but I would like to give him an honorary adopter award, teamwork award, for really driving that relationship and making that successful within Udemy. We also have Adavinta. So these are folks based out of Spain. Sergio and Claudio have been tremendous contributors back to the project. Iker, if you came to, I believe it was the November town hall. So Iker gave us a case study of how Adavinta is using DataHub there. And then we recently had Judith joined the community. So just huge shout out to these folks. They're super helpful, and I'm sure you've seen them in Slack as well. From a project level, we have thinking about, the last two releases, we had 176 PRs merged in the last month or so, which is 44 more than January. So huge volume of work coming through there. I think this is our top number of contributors to the project. We're up to 47, including 20 new contributors over the last month. So, just a huge range of community contributions coming in, both, kind of tenured folks and also new folks as well. In terms of kind of highlights of what we've shipped, we have we have two new incubating sources, so Tableau and ClickHouse. Both of those are out and about and ready for feedback and usage from the community. We also rolled out Kafka stateful ingestion, supporting Avro files. And then for folks that are ingesting metadata from multiple instances of the same platform type, we now support kind of differentiating that. So what does that mean? if your organization has 5 different Postgres production instances, you can now delineate between those so you can kind of better manage or organize your metadata with the DataHub. In terms of UI improvements, we are officially supporting data domains and containers, so that's live and ready for folks to use. We also made some improvements to search in terms of what you can search by. So you can actually search for entities owned by a user or group, just to kind of like streamline that search experience. You can also now edit existing glossary terms within the UI. This is going to be followed by future work to actually manage and create glossary terms from the UI. But this is, in the meantime, you can actually leverage that until we roll that out. Then we also have some improvements around metadata analytics and the analytics tab. A couple of docs improvements. We have a new guide to using search, and then also more robust documentation around our metadata model, which Shirshanka pushed this out while he was technically on vacation. So thank you, Shirshanka, but also take vacation, man. We appreciate you.
Swaroop helped me a bunch, so I think we did it together.
Good. Okay, fair enough. All right, and then another round of shout outs here. So Claudio is actually the person who drove through stateful ingestion. Massive shout out there. I know that Surya on the core DataHub team is super appreciative of your work. Alex and folks within the integration ClickHouse DataHub channel pushed through this PR. This one is really awesome because it was fully led by the community, and we were just kind of there to help facilitate a little bit. So really super appreciative of the work there. And then Edward pushed out YAML-based lineage, and we'll see a demo of that. But I really think this is one that's going to really help folks get a sense of what lineage looks like within DataHub without going, or just kind of a little more quickly making those connections between entities. So excited to hear from Edward in a few minutes. And then if you were in Town Hall in January, I gave a shout out to Danny. He had shared this thread around non-code contributions and how folks can contribute back to open source communities, even if it's not, writing code. And wanted to give a quick shout out or call out these two different ways. So we're seeing blogs around how to deploy DataHub. We also had Excel create a new guide for searching within DataHub. So, understanding what kind of keywords you can use, or really how you can just make the most of searching within the DataHub UI. And then we also had Ibu send out a motion graphic, which I saw this. I just love this. I want this on every visualization I ever use. I just think it's so cool. So this is really just a reminder that, if you're looking for ways to contribute, it doesn't have to be code. Bring your ideas, your experiences, and if you need support in any way, please feel free to reach out to me. I would love to help you be successful there. All right, one last check-in from me. We're going to do a quick roadmap update. So let me jump out of here. So this is our public roadmap. If you've not seen it yet, it's in the same portal as our feature requests, and this is where we're keeping everything up to date in terms of what we're working on. You can also click in here to see both the scope of the work that we're taking on, as well as kind of tagged or linked feature requests. So really the goal here is to just provide visibility into what we're working on and what that work is going to be. So we're going to actually go through pretty much everything in this in progress list today during this session. So we'll be talking about lineage impact analysis, column level lineage update, data quality, and then schema version history. We have a new name for it, but we're addressing it here. And then coming up, still within, we have one month left in Q1. We're going to be tackling some improvements to our API, view-based RBAC functionality. So this is widely requested across the community. We will be rolling that out as well, and then just some general UI improvements. This is where I'm going to be staging our potential initiatives for Q2. So keep an eye here. If you have any questions about this at all, I'm always happy to help you navigate through that. So with all of that in mind, we're going to kick it over to Mr. Shirshanka.
Awesome. So this is the most interesting part of my day, because I get to tell you all of the cool stuff that has happened in DataHub and is about to land. First thing is column level lineage. We're actually calling it fine grained lineage. So we're going to use the two terms interchangeably. Where are we at? We have committed the model, and it supports both dataset to dataset as well as dataset to job lineage. We have APIs and documentation for how to add and query this data. So if you have programmatic integrations that you're dying to kick off, go at it. You'll find that documentation exactly where Maggie was talking about. If you go to the doc site and you look on the left rail and you drop down to metadata modeling, entities, and you drop into dataset, you'll see a section there on fine-grained lineage. And over there, you'll have examples of exactly how you can add this lineage, both to a dataset or to a job that reads or writes to a dataset, and then how to query that lineage information. So that's just the beginning, obviously, but it's a good checkpoint for us. The next step is going to be actually building out integrations with existing sources and producing this kind of fine-grained lineage from those existing emitters. We're still doing an inventory of which sources are actually good targets to start out with. So please let us know if there are ones that you think are good ones for us to go after. It's interesting that most sources do a really bad job of providing column level lineage. And so it's quite a bit of work to actually pull it out. Right after that, we will obviously be showing all of this in the UI. So that's the order of progress that we are planning. So that's the checkpoint on column level lineage. Next slide. All right. So we've talked about schema version history ad infinitum. And as we started building it, we actually built one version of it and then realized there's actually a better way to do it. So we're actually calling this the timeline API. What do we mean by that? It's a unified timeline of changes to entities in the metadata graph. And it's computed across all of the individual fine-grained changes that are happening to entities. So you essentially get a unified timeline of any entity, like a data set. And you can then filter as a consumer whatever categories you care about. So for example, we've got this entity here. This looks like a Hive data set. And we want to see what happened to this data set from 7 days ago to now. And you can see that, oh, well, schemas got added, tags got added, documentation got added, maybe a schema got changed in a backwards incompatible way. And then documentation was further added. So this is kind of a unified timeline across all of these categories of changes. As part of this change, we also added finally an open API server to the DataHub backend. So I don't know how many people love RESTly, but it's a very hard to use REST API. So we want to move towards open API as our public facing REST endpoint. And as part of the timeline API work, we actually put in the work to add in an open API server. So what that means is that the timeline API is served over the open API endpoint, and also, of course, through your friendly DataHub CLI. And we'll go into some details there. Next slide. If you want to think about technically how it's actually built, the metadata model is split up into aspects, right? And each aspect is very fine-grained. So for example, we have an aspect called schema metadata, and we've got another aspect called global tags, and we've got another aspect called dataset properties. And there's lots and lots of aspects. And individual changes are happening to each one of these aspects. So you might have a schema changing, and that might be happening over in the schema metadata aspect. You might have tags being added, and sometimes that happens through the schema metadata aspect, and sometimes it happens through the global tags aspect. So there's a lot of complexity in the lower level model and how changes are happening in there. But what we wanted to provide was actually a semantic way to look at all of these changes in a single way. So at the top level, there are categories like technical schema, tag, documentation. And these high-level categories actually span across these fine-grained aspect changes. And so you can then create a singular unified timeline across all of these categories. So you can almost think about this unified timeline as a projected view that is merged across all of these individual version timelines. So it's pretty cool. It was a lot of fun working on this. A huge shout out to Ryan and Surya, who I collaborated with in building this. And this is just the beginning. I think now that we have this, we're going to be able to build simple things actually now, like schema version history, documentation history, and all sorts of different experiences on top of this much more general API. So that's kind of the high level visual of how to think about it, but how do you get it? Well, it's already there. The CLI was released last night, so you can try it on the quick start using the latest CLI 08.27.1. The server code is also in, obviously, so it's part of quick start. It will be released officially as part of 08.28, so that's the next release coming up. And in terms of like caveats, it's supported only for data sets right now. So the entity type has to be a data set, and it supports these kind of change categories: technical schema, tags, documentation, glossary terms, and ownership. Docs are also up, so you can go read them and send us your feedback. And of course, over to a live demo from Ryan, who's going to walk you through how it looks.
All right, let me take over. Okay, so I've got the UI up here, and so you'll notice that here we've added a couple of links in the drop down here. And specifically, I'm interested in the Open API one. So this is our new Swagger page that Shirshanka mentioned. So this has the Open API spec for the timeline endpoint, and here you can explore it just like any other Swagger page. So if we add an earn and a category of change that we want to search for, then we can get this nice little response of a list of changes that have happened to that particular data set. And so the schema of the response, basically we split each change into a transaction level change that includes a list of change events. So those list out the individual changes that have happened to each category. So that's the Swagger page. And then on the CLI side, we have this DataHub timeline command that we've added. So it has two mandatory parameters, so earn and category. And you can specify a start and end time and a few other parameters as well. And so if we send in that, we get a list of all of the changes that have happened to the technical schema, which is linked to the schema metadata aspect. So we'll see, like, for the first set of changes, we got all of these fields added, and then we've put in some changes where we modified and removed some of the fields in there. And so one of the things you'll probably notice is, so we have a timestamp of each transaction that happened and a semantic version that was computed. So these are all relative. Basically, we compute this as a result of what changes happened. So if a major version change happened, like a backwards incompatible change where a field was removed, then we'll up it to a major version. But if something less significant happened, then it would be a minor or a patch. So I'm also going to go ahead and show that if we add a tag to this data set, we will see a new entry in this list. So right now, this is what we're seeing. So there were some tags that got added and removed. And then if I go in here and I add the needs documentation tag, And then I run it again. We'll see that we have this new entry in the list where it says the tag needs documentation was added to this entity.
This is something people have been asking for this for many months. And so, I'm super excited to start getting some feedback from the community on it. And then also a reminder, we'll be working on the UI components of it. So actually surfacing this information in a way that doesn't require you to go into the CLI. So super exciting stuff happening there. All right. So I'm going to hand it off to Edward, who's going to talk us through some of his contributions back to the project.
Cool, thanks. To start off, can you guys see my screen?
Yes, we can.
All right, awesome. Okay, so hi, my name is Edward Vaisman, and I'm a senior Kafka administrator at Wavelo, here to talk about managing your Lineage and DataHub through the use of YAML files. Just a quick note about Wavelo. We are a new software business that's on a mission to make telecom a breeze. And all that means is that we want to provide flexible and modern software to communication service providers, and in even shorter terms, software as a service telecom. Okay. Also, for those of you who have been on the internet for a while, Wavelo is a part of the Two Cows family. So if that interests you at all, Two Cows is hiring, right? All you have to do is go to twocows.com/careers, or you can message me directly on Slack on the DataHub community, and we can iron out some of the details. Okay, so let's talk about DataHub. Being a member of the Kafka team here at Wavelo, we wanted to provide a data discovery platform to our organization to help find out a little bit more about the event streams that we've been curating within our platform over the past year. That's when we came across DataHub, and we've been toying around with it for the last month or so. But for anybody that's familiar with Kafka or messaging systems in general, there's actually very little out-of-the-box tooling when it comes towards linking your data sets together. Naming standards only really get you so far, which is why when you run the DataHub recipe for Kafka metadata, at most you'll get the individual Kafka topic ingested and maybe some schema-related information if they make use of the schema registry. So to help bridge that gap, we recently contributed a file-based lineage source to DataHub, which will allow you to start linking your data sets together. I would say it's best used as a sort of duct tape while teams are still going through the process of adopting a data ops approach, but it's good to at least get you off the ground, I would say. So let's take a look at DataHub right now. I've already gone through the Docker quick start, and I've ingested some data in here. And being a Kafka guy, I'm going to be interested in data inside Kafka. So I'm going to quickly browse, and I see this sample Kafka data set, and cool, it already has some lineage associated information. But when I browse it, I notice that, the sample Kafka data set doesn't have all the information. It's actually a little bit misleading in the sense that it actually sourced its data from other Kafka topics, right? Which isn't present just by looking at the UI here. So let's go ahead and add some new lineage to it. So the first thing I'm going to look at here is I'm going to look at the recipe file. The only thing you have to pay attention to in the recipe file is that there's two parameters. There's a file, which just a path to our lineage file that's in YAML format, and there's a field called preserve upstream, which I'll talk to at a later point. The type up here you would set to be DataHub lineage file in the latest release of pip. Right now I'm just using the custom plugin that I have. Okay, so let's take a quick peek at example lineage. So your lineage file will kind of look like this, where at the root you'll have the version. Right now it's only version 1. You'll have lineage, and under lineage you'll have a list of entities and their upstream nodes. An entity comprises of the name, the type, environment, and platform. Currently, the only type that would work today is dataset, but that's perfect for what we need to do. And optionally, you can provide upstreams to that dataset. So let's say, let's go back to sample Kafka dataset. I'm going to grab this name, sample Kafka dataset, I'm okay with this, I'm okay with this, I'm okay with this, and I want to add a new upstream for it. So I know that there's, you know, my Kafka upstream somewhere there. And you know what, maybe it's actually also grabbing data from another data source. So I'm going to keep this S3 data set over here. I'm going to quickly just run this through the DataHub ingest. Recipe, rest, sync. Okay, so it's already produced one work unit for this earn. Let's go back to DataHub UI. I'm going to do a quick refresh. And boom, now we have lineage between our sample Kafka data set and our, other data sets. Currently, only data set to data set connections would work, but depending on how that data process PR goes, we might also want to include like an application in between. Very important for like a event streaming world where we have microservices in between that we may want to link in between Kafka topics or something. And as I promised, let's talk about preserve upstream. So by default, this is true. And all this field does is it determines whether or not you want to keep the existing lineage that already exists within DataHub. So if I was to go inside this lineage file and I wanted to modify one of my upstreams, let's say, let's remove that. And let's just do my new upstream, run the ingestion again. The work unit's replaced and I refresh, the upstream just gets appended on. If you wanted to hard replace it, let's say we accidentally messed up and those upstreams are not current, we would set this to false. Run it again. Do a quick refresh. And now our data set only has one upstream associated with it. And that's really all it takes to get lineage hooked up through a YAML file. Just a quick caveat. It only goes one layer deep, so you can't just start adding another upstream here. It won't look through it. So if you wanted to add another lineage for maybe this new upstream, you would start with entity and name, type dataset environment prod, platform Kafka, and then you would provide another upstream for that. And that's all she wrote. Thanks.
Edward, I am so excited about this one. I think this is like really going to supercharge folks getting lineage set up for maybe like less well supported data stores. So seriously, thank you so much. There was one question in chat around how do you tackle schema drift?
So this only affects the upstream aspect. So that's the only thing that this file is touching. Anything that was a part of that data set before is preserved because we're not even adding anything different to the aspects.
All right, let's jump over to Mr. Gabe and Mr. Dexter. We're going to be talking lineage impact analysis.
Yeah, thank you again, Edward, for demoing that lineage feature. That's super, that was super cool surprise to see. And yeah, I think that'll be really helpful. So I've been doing so much like creating these custom JSON files for lineage, and it's very tedious and painful. So this is so much. I really appreciate that. Thank you. All right. So then continuing the lineage theme, Dexter and I are going to talk to you about a new feature, Lineage Impact Analysis. I'm really excited to talk about this feature at Town Hall, especially because I know this has just been requested so much from folks in the community. And I'm really happy to be able to finally present it. We've incorporated a lot of that feedback, and I feel like this is a really collaborative project between us and all sorts of folks in the community. So thank you, and I'm excited to demo it. So what is a lineage impact analysis? So essentially, what you can do now is for a data set, you can go and view a collection of all the downstreams of your data set together in one grouping. So not just that first layer that we were showing you previously, but actually we'll go across all the layers and bring it together into a collection. And this collection you can view, but you can also filter it using all different types of filters that you can use in the search that you're used to. So you can filter by tags, platform, entity type. Now, with the recent update we gave, you can filter by owner. You can also have a free text search box to just do free search across all of the downstreams. And then we added a new filter just for the impact analysis section, which is the level of dependency. So you can say, I actually want to see only things that are 2 layers deep or 3 layers deep away from the current entity that I'm looking at. Then finally, once you have that collection, viewing it is one thing, but what are you going to do? What do you want to do with it? And so we've added the ability to download this collection that you filtered as a CSV. You can take it with you and then go do any other action based on that. So on the motivation front, I think about 2 different main use cases here. So there's the proactive side and the reactive side. On the reactive side, that's sort of the data ops use case. Maybe something's gone wrong with your data set, and you need to know, what do I do about it? Who do I alert? Who do I inform? How do I make this right? So you can go in and find who's depending on your data set. If it maybe your stream job is delayed or a data quality check's gone wrong or something like that, how can you manage this incident? But there's also the proactive side, which is you want to make a change and you want to know before you go ahead, who do you have to discuss this change with, who might be impacted in a similar fashion, and who do you essentially want to reach out to and make sure that you're going to deprecate a data set or change a column or do a backfill or something like that. Who do you need to talk to? And again, thanks to the community for great conversations that helped us understand better how to build this feature and what exactly impact analysis, what iteration of impact analysis would be useful to folks. And I want to give a special shout out to Stephen Poe. We had a lot of really fantastic conversations and he was super helpful in helping us clarify how we can make this most useful. All right, so now I want to go into a live demo of this feature so you can see it in action. So I made this raw events Kafka data set. And maybe this is some event stream that we have going on. And all of a sudden, I realize this event stream is delayed and I need to know what to do about it. So if I go into the Lineage tab, by default, I just see there's one downstream consumer. And so on the surface level, it might seem like there isn't that much impact of this Kafka stream being delayed. But now I can jump into the impact analysis section of the Lineage tab and see not just that first layer of Lineage, but all the different layers beyond that. And so when I jump in, we'll do a little search across the graph. And actually, I have to give a shout out to Ibu. This is Ibu's little animated GIF that they contributed. Now is our loading indicator for the impact analysis section. And this, after I jump into that impact analysis view, I see all the different entities, all the different layers deep. So you can see here in the top right corner of the entity row is how far away the connection is from this source data set. So for example, dim users is a few steps away. And I can open this filter panel and say, actually, I need to go and let the analysts know. So I actually just want to filter by looker and just find all these looker charts and dashboards that depend on this data set. Once I have this subset of my dependencies filtered down, I can go into this little menu and hit download, name my file. And then when I download it, it pops up as a CSV. I can just show you after I open it, it's going to have the earn, the name, the entity type, description. You'll see ownership information, platform tags and terms if those are filled out, the level of dependency, and then also a URL that will bring you to the entity in question. So then just as this is the end of the demo, but as one final Easter egg, we thought this download CSV feature is super cool. And so something that we did just for fun was add it to the search page. So if I search for raw events here, you'll see that same menu and I can download any group of search results as CSV. This is also in all the different embedded search elements. So if I go to, for example, my ownership page, you can download a CSV there, and whatever filters you've applied are going to be included here as well. So Really excited to hear your feedback on this download CSV universally. Let us know what you think. And also, of course, impact analysis as well. Yeah, so that's the demo. Then I just wanted to touch on one thing before I cut over to Dexter. So just on the what's next, so Shirshanka was talking a little bit about how we're moving toward column level lineage and getting that metadata inside of DataHub. And so once we have that, you'll be able to do, what you'll see coming down is the ability to say, if I was going to change this column, what is the impact of that? And we'll be able to have impact analysis, not just at the entity level, but also the column levels. So things like schema change management will be easier. And then obviously, what's next is not just determined by what's on this slide, but it's also determined by you folks in the community. So please let us know, try it out, and I really look forward to reading your feedback. Now I'll hand it over to Dexter, and he can talk about the amazing engineering and architecture that went into this feature.
Gabe, before you switch over, would you mind talking about the API really quickly?
Oh, yeah. Thank you. Yeah, so in addition to being able to view this through the UI, we also have an API that you can hit to query and get this information. And in the API, it's not just those columns that you see in the CSV, but you can fetch any metadata about these entities. So you can programmatically say, I want to get all the downstreams across all levels for this data set, and just give me, you can provide filters and search queries just like you can in the UI. So essentially, everything you see here in the UI, you're able to express through our GraphQL API, and we'll share out documentation on that afterwards. Yeah, thank you.
Awesome. All right, so let me go really quickly through how the backend works. So in order to do this, we have to change some fundamentals of how Lineage works in the backend. Basically, let me go over how it was working before. After no code change that we did last year, we were able to put relationship annotations on our models to note that this field called dataset in an upstream lineage aspect means it's a downstream of lineage between these entity types. And these relationship annotations are converted into edges in the graph index. So these are some example edges that you can see here. For example, a logging event is a downstream of sample hype dataset. Data job user creation consumes this dataset, and so on and so forth. So how this edge is provided is the entity on the left side is the source earn of the entity, and the entity on the right side are the values inside the aspects. So what is the source earn, what is the value in the aspect decides the direction of the edge in the graph index. Now the problem is that this is not necessarily the direction of the edge in the lineage graph. So if you see above, we go from dataset to dataset, and then dataset to data job, and so on in the lineage graph on the top right. But the direction of the edges are sometimes the opposite. So you can see that the logging event is downstream of sample hype dataset, but the direction of the edge in the lineage graph is the opposite. While if you see the very bottom, data job user deletions creates this sorry, that's a typo. It produces this data set, and that is the same as the lineage direction on the graph above. So what we had to do before was for front end to whitelist a bunch of these edges and figure out how to query for on our graph service. So our graph service has no knowledge about how lineage works, and it just has knowledge about these edges. And now the problem with multi-hop when we try to hop multiple times is that we need to know what a lineage edge is on the back end. So we had our initial set of iterations. If you go to the next slides, Gabe, next slide. To build this lineage registry where it's all no code. For given a relationship annotations, we add a few fields called is lineage is true, means it will show up in the lineage graph, and this is an actual lineage edge, and some other metadata about this relationship, so that we can build a lineage registry that says, given an entity type, what are the upstream data sets? How do we query for them in the graph database? And what are the downstream edges, and how do we query for them in the graph database? So for example, if you see this data job lineage registry, it says that to get the upstream entities of this data job, you need to look for these type of edges in the graph database. One is consumes. So basically, I wanted to see what this data job consumes, which is actually the upstream of this data job, as well as the downstream of. So what is this data job downstream of? Which means that what this data job is downstream of are upstreams of this data job, right? It's a little confusing, but bear with me here. And then the same thing for downstream. So like here are the edges to look for in the Graph database to find the downstreams. Now, the contract between the front end and back end is now much simpler. The front end tells us, give me all the upstreams and downstream lineages without knowing anything about edge types, anything about anything like that. The lineage registry in the back end decides, oh, these are the edges we need to fetch on the graph index, and fetches those special edges. So now, so as a side effect, our lineage graph has also improved by saying all the entities that shows up in the lineage graph and the edges that show up in the lineage graph are defined on the back end now through these relationship annotations. Now that this is set up, we can move on to how multi-hop works. So basically, now that we can do a single hop, if you go to the next one, Gabe. Now that we can do a single hop, we can easily do a multi-hop. We started work on Elasticsearch because Elasticsearch is the mainly used GraphDB right now. And we'll be implementing this in Neo4j soon. In Elasticsearch, there's no way to go multiple hops easily because it's not a graph database. So basically, we had to do a simple BFS across the graph index. So given an entity, given the set of entities from the last hop, fetch all the downstream edges. So do one hop to the next set of edges, and then keep track of all the visited nodes and do all the hops until we reach the leaf nodes. We batch all the requests to minimize number of queries. So we don't do it per entity, we do it per hop. So per hop is one request to Elasticsearch. And then we cache the final set of errands, all the errands that were impacted by this data set. Now, once we have the final set of errands, we query the search request. So we do search across entities the same way we do the search on the main search page, but with this added earn filter saying anything returned by this search needs to be among these errands that are impacted by the data set. By doing so, we're able to support that embedded search experience that you saw in the demo. So now, like once we have the Neo4j implementation of that, the first part, we'll have this working on Neo4j as well. If you have any questions on this, please ping either Gabe or me. We're open to any suggestions.
I gotta say, this is one of my favorite features to come out ever within DataHub. Super excited about it and really appreciate, want to mimic what, or echo what Gabe said. We've had a ton of fantastic feedback from the community to really like understand these use cases, to understand what workflows we want to empower. So massive shout out there. And again, if you have feedback, if you have additional use cases that we want to consider, we are all ears. You're more than welcome to reach out at any given moment. All right, Mr. John, where are you? There you are.
Hey folks. So I'm going to be talking about an integration we've worked on in the past few weeks to extract quality insights from Great Expectations and surface them inside of DataHub. So we'll get right into it. First, we'll just kind of go over what is Great Expectations for the folks who may be unaware. Basically, Great Expectations is a way to define assertions or tests on particular data assets and then evaluate them repeatedly over time to track the quality of a data set. The goal being to maintain the data set's quality through time as it changes. So some examples I pulled from the Great Expectations documentation is this. So you would define this in your Python code, basically an expectation of what you would expect from a data set, either at the table level or at the column level. So in this case, we have an example that expects the column named passenger count to always have a value that's between some minimum and some maximum. Additionally, there's a large set of sort of standard expectations, as they call them, that you can use to validate different characteristics of your table. So for example, expecting columns to exist, or the table columns, the structure of the schema to match some predefined list, etc. So what we got from the community was a request to display the outcomes of the Great Expectations assertion suites in DataHub. For all the perfectionists out there, we had to make one modification to that request. So the solution they wanted to see is, as an end user, to be able to see the types of assertions, specifically the results of running the assertions associated with a data set inside of DataHub. Additionally, with the requirement to be able to see the assertion runs over time or over history. And so now I'm just going to jump right into a demo where I'll talk about how to actually configure the integration, and then I'll run some expectations and show you what the output looks like once we've ingested that into DataHub. So I'm going to step over to a local Great Expectations project that I've got here. In my main Great Expectations configuration YAML, I've configured a connection to a local Postgres DB, which contains two tables. The one we'll be interested in is called Taxi Data Jan 19th, which contains some information about taxi cab rides given in January of 2019. So we've already gone ahead and defined a set of expectations that I'd like to run against this table. So basically just some tests or assertions. A few of them that we have in here are, expecting the table columns to match a predefined list, expecting the row count to be between a particular minimum and max, and expecting a column to always have values that fall into a finite set, among a few other types of expectations. Once we've defined our expectations, we have to use a checkpoint to actually run the expectations against our Taxi Jan 19th table. So I'm going to go into a checkpoint file that I've configured. And you can see that we configure this to run against the Taxi Jan 19th table. And we're using that suite, which is just a group of expectations that I previously showed you. There's also an interesting configuration called action list. And this is where we're going to configure the integration with DataHub. So actions in Great Expectations are a way to run code once a checkpoint has been hit. And so if you go down to line 20, you can see what the DataHub integration will look like. It's basically 5 lines that invokes a DataHub specific action when my assertion suite runs. And what it'll do is actually sync that to my DataHub instance, which is running on localhost 8080. So now I'm going to run through the process of ingesting an assertion run into DataHub. First thing we'll need to do in our Great Expectations environment is actually just install the Great Expectations plugin of Acryl DataHub. Now, I've already gotten that installed, so I'm just going to skip that step. But once we've done that, we can run this checkpoint, and hopefully this will execute the suite as well as push data into my local DataHub. Okay, so you can see that the suite ran, and it says that all of the assertions passed. Specifically, there were 9 of them. Now I'm going to navigate over to DataHub and show you what it will look like inside of DataHub. So I'm just going to search for that table, and I'm going to click it. And what you'll immediately notice is a new indicator on the side of the title here, which indicates that this data set is passing all of the assertions that DataHub is aware of. You'll also notice a new tab called Validation. I'm going to go ahead and click on that to see the current status of this data set. What you can see inside of here is a top-level summary saying that all of the assertions that DataHub is aware of are currently passing for this data set. You can also see kind of human English descriptions of each type of assertion. And if you hover over it, you can see the native Great Expectations operator that was run. Finally, you can pop these open and actually check the history of the runs. And you can see that we've only run this one time and it passed. We can also see the information about the run output here. So this is what a succeeding set of expectations or assertions on a table can look like in DataHub. Now I'm going to go ahead and show you what failing expectations looks like. And for that, I'll go to this Feb 19th table. So we can see that this one's actually failing one of 9 of its assertions that we know about. And we could go over here to actually see that this is the assertion that's failing. If we pop that open, we can see when it was run. Okay, this one was actually run quite a bit of time ago for the last time. And we can see that it failed with an invalid count of 7, meaning that 7 values of the vendor ID column were null. Finally, I'm going to show you what it looks like when there's a little bit more information in our table here. So in this case, we can look back for a whole year and see the output of every single time that this assertion has run against the data set. So yeah, this is pretty much the demo. Initially, we will support Great Expectations, but we've modeled this in a fairly general purpose way with this concept of assertions, such that we can support things like DQ, among other types of validation systems. So now I'm going to navigate back to the presentation here. So quick configuration recap for Great Expectations in particular. In your Great Expectations environment, you're going to want to install Acryl DataHub Great Expectations plugin. You're going to want to add the DataHub validation action to any checkpoints you have. You're going to want to execute them, and then you can view the results in DataHub as assertions. So just briefly, I'll talk about how this works under the hood, particularly the modeling. We have a new entity on DataHub that we call assertion. Assertion can be associated with other entities, and it does exactly what you would think. It just defines conditions that are executed against a particular entity. We also have a special time series aspect we've added called assertion run event. And this is basically what powers that overtime view, historical view. Every time an assertion runs, an assertion run event will be produced to give different information about the assertion run, like its status, its results, maybe how much time it took, things like that. And in this case, we have just a basic relationship between the assertion entity and the data set. So now I'll quickly cover the availability. In DataHub version 0828, which is the next release, we will be shipping support for dataset table and column assertions from Great Expectations. Support for Great Expectations v3 API, which is their latest API. We're going to push assertion results, as you saw, in real time via that checkpoint action. And we're going to support the SQL Alchemy execution engine inside of Great Expectations. Now, there are other engines like Spark and Pandas, but that will be not in the V1 support. Finally, we'll have a GraphQL API, which will allow you to check the assertion status for a particular data set. And I think this is actually pretty powerful because it allows you to build automated workflows that only proceed if maybe some input data sets are actually passing their most recent assertions. Finally, I'll just talk about where we see this feature going, starting with some improvements we have to make already to the Great Expectations connector. We want to support other execution engines, like I alluded to, Spark, Pandas, support for legacy APIs, depending on the feedback we get from the community. I think there are some people who are still working with the V2 APIs, as V3 is actually kind of new. Support for cross dataset assertions, which is an advanced feature in Great Expectations. Support for conditional expectations, which is basically expectations that only apply to a subset of a table based on some filtering criteria. Finally, the new integrations we'd like to support. Again, this will be driven based on community demand, but we have in mind DQ and potentially even Soda SQL. So help the core team out, tell us what you want to see here, and we'll do our best to prioritize it. Okay, that's it for me.
Just based on demand here, DBT test.
Okay. DBT test. All right, that's it. Thanks. Back to you, Maggie.
Awesome. A ton of love in the chat. So John, if you want to take a look there and see if there's any outstanding questions. Folks, this has been maybe my favorite town hall ever. I think I say that every month, but I mean it. I really appreciate all of the awesome work. Thanks for coming out. We can stick around for a few minutes if anybody has questions and want to ask them live. And otherwise, we will see you in Slack, friends.